Hi everyone, this is Top 3D Shop, and in this video, you will learn about the shining 3D EinScan Pro HD handheld 3D scanner. As we've already mentioned in our previous videos dedicated to shining 3D equipment, the manufacturer has been on the market since 2004. Headquartered in China, the company conducts all the development and research in cooperation with its branches in Stuttgart, Germany, and San Francisco, USA. The range of shining 3D scanners is extensive and covers almost all possible tasks related to 3D scanning, such as dentistry, art objects digitization, reverse engineering, metrology inspection, and so on. We've already reviewed a number of products by Shining 3D on our channel, including the budget-friendly EinScan SP and professional hybrid EinScan HX 3D scanners. Now we'd like to tell you about the EinScan Pro HD, which sits somewhere in between the SP and HX models regarding both the price and its capabilities. As usual, let's start with the unboxing and technical specifications. The scanner is shipped in a small cardboard box which contains a power cord and another box with a stylish design and a handle. Inside there is an envelope with a list of everything that should be in the package and a license key for the Solid Edge Shining 3D Edition software, which is needed to process captured scans and turn them into full 3D models. Next is a black velvet bag containing a panel with circles and square in the center. It's a calibration board. The following items are an external 12-volt 5-amp FSP branded power supply unit and a USB flash drive with instructions and all the necessary software. Then we find a plastic stand for calibration, smartphone holder, we'll tell you how to use it later, small bracket for mounting the scanner on a tripod, another plastic part with a double-sided tape for fixing the cords to the table, a small scraper to remove markers from objects, and the scanner itself with the cord. It is packed in a bag and also wrapped in a film. In addition, there are markers for scanning, quite a few of them to be enough for a good while. In any case, you can always buy them separately or even print them by yourself if you want to. Now, let's take a closer look at the scanner and examine its technical specifications. The EinScan Pro HD adopts the technology of structured light scanning. It displays special patterns onto the object using an LED projector located in the center of the scanner. Two cameras at different angles record the distortion of these patterns on the object, so that special software called EXScan can determine the distance between individual points and from the scanner. As we've already mentioned, the Pro HD somewhat resembles two other scanners by Shining 3D, namely the SP and HX models. The EinScan Pro HD has two main scanning modes: manual, like the HX, in which you hold the scanner in your hand and move it around the object, gradually gathering a three-dimensional point cloud, and fixed, as in the SP. In this case, the scanner is mounted on a tripod and the object to be scanned should be rotated in front of it. Thus, we get separate scans to be subsequently aligned. The technical specs table shows that every mode is divided into two submodes. In case with the manual mode, you can choose between HD and rapid scanning, the main difference lying in the accuracy of scans. With HD scanning, it can reach an impressive 45 thousandths of a millimeter, while in rapid mode, it is only 1/10 of a millimeter. Still, it doesn't mean that rapid scan is bad or low quality. It really depends on your goals. If you need to get an accurate scan of a not very large object with small elements, then opt for HD mode, although it's a little slower and requires a lot of computer resources. But if you need to scan a large object without having to capture small details, rapid mode will be enough. It requires less computer power and makes the scanning and processing much faster. In our tests, we will clearly show the difference between these two modes. Another important parameter in handheld scanning mode is the so-called volumetric accuracy. That is, a possible deviation of the scanned object per 1 meter. In both rapid and HD mode, it is 0.3 millimeters. Fixed scanning offers two submodes too. In the first case, you should rotate the object manually in front of the scanner mounted on a tripod. The second option presupposes using an automatic turntable. This device is not included in the basic package. It comes with the industrial pack, which, apart from the turntable with coded targets on it, includes a handy tripod, a power unit, and a USB cable to connect the device to a computer. The scanning accuracy in fixed modes is 4/100ths of a millimeter, which is about the same as in the handheld HD mode. The difference between scanning with or without a turntable is only the way individual scans are aligned. The turntable has special targets on it which help to align scans. With the basic Pro HD package, you won't be able to make full-color scans with textures. However, there is a special color pack add-on which allows color and texture scanning. We'll also check it out in this review. The design of the EinScan Pro HD is quite typical for handheld scanners. The front of the device contains the cameras and projector. On the opposite side, there is a rubberized handle for convenient manual scanning. It also has a button to start or stop scanning and 2 more buttons to zoom in and out or change the brightness. Above is an RGB LED backlight that helps to determine the optimal distance from the scanner to the object using a color indication. Let's move on to the connection, calibration, and tests. The connection procedure is quite straightforward. On the scanner side, the cord is already secured. On the opposite side, next to the USB connector, there is a power plug right on the cord. The USB connector must be plugged into the USB port of the computer. Be sure to employ the USB 3.0 as the scanner transmits a lot of data to the computer while in use. Also, pay attention to the recommended computer requirements. You will need a Core i7 processor of 8th gen or above, NVIDIA GTX 1060 graphics card with 4 GB of video memory, and at least 32 GB of RAM. The minimum requirements are a bit lower, but in this case, manual scanning will work poorly, especially in HD mode. Everything will lag, and from time to time, you'll be running short of RAM. If you can, use a computer which is even more powerful than the recommended configuration. So let's connect the scanner to the computer. The system should detect it automatically. The next step is to install the EXScan software. The installation file is available on the USB drive, but it's better to download the latest version from the Shining 3D website. The EinScan Pro HD needs a version called EXScan Pro. When launching the software for the first time, you'll be prompted to register and activate the application online. EXScan may also ask you to update the scanner firmware before the activation. It runs automatically and takes a few minutes. Now we need to calibrate the scanner. The process consists of 5 simple steps. First, take the calibration board from the kit and place it on the table as shown on the picture in the software. Hold the scanner horizontally and gradually lift it over the center of the panel. The software will show several bars gradually turning green, which indicate the distance from the scanner to the board. The point is to make all the bars green. After this, place the calibration board on the plastic stand, as shown in the picture, and repeat the actions from the previous step. Perform the procedure 3 more times, turning the panel 90 degrees. The software will process the data and indicate the calibration deviation. The process has been completed. In our case, the deviation was 0.03 of a pixel. Now we're ready to scan. For the first test, we took a car part. It is an H-arm from a BMW. The part is of a medium size and has small elements such as letters and a convex mesh on one side. Some of its areas are shiny, and there are also black areas where the silent blocks are located. We already scanned this arm in the EinScan HX review using the laser scan mode. The Pro HD model does not use such technology, so we had to choose between rapid and HD handheld scanning. Let's look at the parameters of these 2 modes and check the variation between the scans when using different settings. On entering HD mode, we see a window with several parameters. In the first column, we should choose between texture and non-texture scanning. As we have said before, the basic package does not have a color camera, so it's not possible to use texture scan mode. Neither do we need it in our test. In the second column, we are to choose the method of alignment. There are 3 of them in HD mode. The first is alignment by geometry features. It uses reliefs and curves of the object to align scans. The second is by markers. Here you should cover the whole part with markers from the kit, and the scans will be aligned based on the location of these markers. And the last one is hybrid. This mode uses both features and markers, being therefore the most versatile method. Even if some areas miss markers, the scanner can do with object features. Next, we need to choose the operation mode, classic or high detail. Both modes scan at a speed of 10 frames per second, but in the high detail option, you will obviously get more detailed scans with small elements, minor irregularities on the surface, and so on. It is not recommended to use this mode to scan objects larger than 1 meter. Such scans will turn out bulky and hard to process. The last important parameter is the scanning resolution. In HD mode, you can change it from 3mm to 0.2mm. Perhaps the more correct name for this parameter would be the density of point cloud obtained during scanning. For geometrically simple objects with smooth planes, sharp angles, and no small elements, set lower resolution. For objects with complex shapes and fine details, the resolution should be high. Keep in mind, however, that the higher the resolution, the more data your computer will have to process. Therefore, you will need more time to process the scans. Choose the resolution according to your goals and the capabilities of your computer. In rapid scan mode, most of the parameters are the same, except it offers a fourth option of alignment by textures if the scanning with the color camera is enabled. The operation modes are also slightly different. Here we have Classic, Lightning, and Lightning plus Refine. In Classic mode, the Pro HD scans at 15 frames per second using the resolution set in the next column. In Lightning mode, the device scans at 30 frames per second and the minimum resolution of 1mm, and then the program will interpolate the scan to be resolution specified in the last column. Lightning plus Refine mode performs the same way, except you'll be able to choose the resolution after the scan is finished and the software will optimize it by retopology. For illustrative purposes, we scanned the same area of the H-arm in different modes with different settings, so you can clearly see the variation of scan quality. Obviously, this object should be scanned in HD mode with high detail and resolution. We have a powerful computer that allows us to do this. Let's confirm these settings and enter the scanning menu. Here we can see a few more parameters. Brightness should be low for light-colored objects and high for dark ones. However, there's not much sense in adjusting the brightness at this stage. You can change it with the scanner buttons at the beginning and throughout the scanning process if necessary. The parameter Flat Detection is meant to improve scanning of smooth and flat surfaces. You can leave this parameter always on. For this test, we decided to use hybrid alignment and covered the whole part with markers. They should be placed rather tightly and in a random order, so that at least 4 markers would always be visible to the scanner. It is also better to place them only on flat surfaces, so it will be easier to fill the holes from the markers on the model. Now, put the part on the table and start scanning. Press the Start button on the device, the preview mode will start. Point the scanner at the object and adjust the brightness so the surface can be seen as good as possible. You can change the brightness in the program or press Start twice and adjust it with the plus and minus buttons. Once the optimal brightness is set, press Start again and proceed to scanning. Slowly move the device over the object, gradually collecting the data. Be sure to maintain an optimal distance from the scanner to the object, which is about half a meter. Special bars in the software are designed to help with that. These bars light up in different colors. Blue means the scanner is too far away, red means it's too close, and green indicates the optimal distance. You can see the same color indication on the scanner itself above the buttons. This eliminates the need to constantly look at the computer screen when scanning. However, it is still necessary to keep an eye on the screen because you have to see what you've managed to capture and what else needs to be scanned. There is also a way to simplify this task. The scanner comes with a special mount that allows you to attach a smartphone to the scanner and display the image on it from your computer. This does not require specialized software. You can use any program for remote access such as TeamViewer or AnyDesk to display the image. Keep moving the scanner around the object to collect as much data as possible. When all the information has been gathered, press the Start button again. The scanner captured not only the part itself, but also the table on which the object lay, with some redundant elements remaining here and there. All that has to be removed by means of editing tools at the bottom of the window. Select the lasso tool, hold Shift, highlight unnecessary areas, remove them, and confirm the changes. If you need to scan some extra areas, you can press Start again and continue scanning. It may also be useful to change the brightness during the process to capture dark or light areas. In our case, it took about 10 to 12 minutes to scan one side. When everything has been scanned, click the Stop button in the program, and EXScan will create a point cloud from the received data. Now we need to scan the other side. For this, we go to the Project Group tab, create a new project with the same parameters, turn the part over, and repeat the first step. When the other side is ready, it is necessary to align the two scans. Click on the Align button and choose the project from which the scan will be fixed and the project to be aligned. There are 3 types of alignment. The first is by geometry features, which EXScan will use to perform the procedure automatically. The second is manual, where it is needed to specify at least 3 common points on both scans, and the software will use them for alignment. And the third mode is by markers. If there are enough of them, it is recommended to utilize this method. If the scans are aligned correctly, you will end up with the whole part. Now we need to convert the point cloud into a full 3D model. Click the Mesh Model button and select one of the 2 options, to leave the model as it is without additional processing, or to make a watertight solid model so the software fills all the holes. There are several more functions such as filtering, smoothing, removing small floating parts, limiting the number of triangles, removing spikes, and automatic marker hole filling. Technical models are usually exported in their original form in order to minimize geometric distortion during processing, as such scans are rarely used immediately after scanning. As a rule, technical scans have to be converted into full parametric models using the scan as a reference. For this, the scanner comes with the license for the Solid Edge Shining 3D Edition from Siemens, which allows defining all the planes, holes, curves, and edges on a scan to be turned into a parametric 3D model. Depending on the scanning mode, resolution, and the power of your computer, making a mesh can take from 1 to 15 minutes. After that, we go to the post-processing menu. There are several tools to modify the resulting mesh: simplification, smoothing, removing small floating parts, automatic hole filling, and so on. It is also possible to fill the holes manually with one of the 3 suggested algorithms. The part turned out very well. All inscriptions, small elements, most of the holes, and even scratches were captured. Only the deep holes in the silent blocks could not be scanned completely. But it's not surprising. The light from the projector just cannot reach such areas. For the sake of interest, we also tried to create a watertight mesh with automatic hole filling. As expected, it came out quite decent too. After this step, the model can be exported in a common 3D format. As an example of the absence of necessity and high resolution and detail, we tried scanning the body of an electric guitar with one of the fastest modes: rapid handheld scanning enhanced by lightning operation mode with a resolution of 0.5 mm. The body of the guitar was also covered with markers, so there would be no difficulties with alignment. Similar to the first test, the 2 sides were scanned separately and the projects were aligned by markers. It took literally 1.5 minutes to scan each side. Compared to the HD scanning, it also took a fraction of the time to process the scans and create a mesh. In the end, we got quite an acceptable scan which can be used for further work. All planes, curves, and cavities turned out fine. And taking into account that we spent about 15 minutes on the whole process, of which 5 minutes were spent on sticking the markers, the result can be considered excellent. For the third test, we decided to scan an art object. 3D scanning is often used in museums to digitize statues, sculptures, and paintings as well. We already scanned a painting made of leather in the EinScan HX review. For this one, we took a similar picture, only a little larger. Now it's time to make use of an add-on color camera and try texture mode. It looks like a small block with a USB plug and a fixation mechanism. To attach the camera, you need to remove the cover plug on the scanner, connect the camera to the USB port, and turn the plastic lever fixing the camera on the device. After that, it is necessary to recalibrate the scanner. In addition to the 5 basic steps, you will have to perform white balance calibration. Put the board white side up and simply move the scanner away until EXScan signals that the white balance calibration is complete. For the picture, we also chose HD mode since it was needed to capture everything down to the smallest details. In addition, we wanted to get a seamless model from all sides. And while the front of the picture has more than enough geometric features for the alignment, the back side is flat and has no relief. Therefore, we put markers on the back as well as on one of the sides for the future scans to be successfully aligned by hybrid mode. The front side was first to be scanned. It was important to move the scanner over the picture slowly enough to gather information evenly. Besides, it was necessary to properly scan the picture frame, especially the part with markers. We changed the brightness in the process to scan both dark and bright areas of the picture. Likewise, we had to rotate the scanner at different angles to scan corners and areas with overhanging elements and leather folds. As a result, we gathered enough data and the front side scanning was finished. There were some areas that couldn't be shown to the scanner, but they were few and rather insignificant. Dealing with the backside was less troublesome since the alignment by markers is always much easier than by features. The scans were matched by common markers on one of the sides. A watertight model was chosen for the mesh. When scanning with textures, the post-processing menu provides the option to change their brightness and contrast. If we disable textures, you can see how detailed the scan is. Every crease is visible. Even the relief of different types of leather can be seen. A very impressive result. The only problem is markers left on the textures. These cannot be removed by means of EXScan. But we can use a trick which was already shown in the EinScan HX review. If you export a model in OBJ format, the textures will be in a separate JPG file. Open it in a graphics editor, for example Photoshop, and manually remove all the markers, redrawing the deleted areas or replace those spots with similar areas without markers. Keep in mind that you shouldn't change the resolution and size of the images, otherwise they can't be smoothly superimposed on the model. As a result, we got this model. The output is really great. In our next test, we decided to scan a smaller object in fixed mode. It is a nylon part from a coffee machine. It has small elements, indentations, and holes. There are two ways to use fixed mode. You can either rotate the object manually in front of the scanner mounted on a tripod, or you can use a turntable, which is included in the industrial pack or purchased separately. We do have the turntable, so we decided to try it. We will not go into details about scanning in fixed mode. We've already covered this topic in the video about the EinScan SP. The settings and parameters are virtually the same here. Put the object on the turntable and mount the scanner on the tripod, aiming it at the object. Set the brightness or turn on the HDR mode, choose the alignment method. In our case, we aligned the scans by coded targets located on the turntable. Select how many steps the table will take in one full turn and start scanning. The scanner will make one shot per each rotation step and align all scans using the algorithm specified in the settings. After that, you need to turn the part and repeat the same procedure. If necessary, the object can also be scanned in other positions until enough data is obtained. We ended up with this scan. The part is quite complex and has areas which the scanner cannot see. However, the model provides more than enough data for further use. All of the small elements, including latches, holes, and the like, were scanned. For the last test, we took a small steel gear from the same coffee machine. The main difficulty here is the symmetrical shape of the part, so it is necessary to use markers, but we can place them only on the bottom. On other sides, they simply wouldn't fit. That is why we used a method in which markers are placed not only on the object itself, but also on the surface around. The velvet bag from the calibration board suits well for this purpose. It is advisable to coat steel parts with matting spray before scanning to avoid unnecessary glare and reflection. We decided to make the task more challenging and scan without matting. In fact, no major difficulties arose during scanning, so we will not focus on the process. In the end, we got this model. It has some minor flaws, but all the necessary information was captured, even the hole in the center, so the quality is just fine. Let's draw a conclusion. As expected, like all shining 3D scanners, the EinScan Pro HD coped with all the tasks without any problems. Its main advantage is, of course, its versatility. The device can scan both large objects in handheld mode and tiny parts when used on a tripod. The settings and modes can be extensively varied to suit specific purposes. The lack of a color camera and a turntable in the basic package can be considered a disadvantage. On the other hand, this means you don't have to overpay for the complete set if you don't need it. Otherwise, you can always buy these add-ons separately. This is Top 3D Shop with the EinScan Pro HD Handheld 3D Scanner review. Subscribe to our channel, leave your comments below, and hit the like button if you've enjoyed the video. See you soon!